Jax's revenge domain. She thought my login credentials gave her access to engineering brilliance. They gave her a one-way ticket to career suicide. I watched her present electrical schematics that would have killed people, then watched the whole thing blow up in her face like a poorly wired circuit breaker. This is how I used 25 years of electrical engineering knowledge to fry someone who tried to steal my life's work. My name is Nathan Pierce, 49 years old, divorced father of 2, and according to my performance reviews at Atlas Strategic Solutions, technically exceptional, but lacking the people skills for client management. Translation: he can design power systems that keep military bases running during combat, but we can't imagine him glad-handing politicians at fundraising dinners. I've spent 8 years in the Navy as an electrical systems specialist, followed by 17 years designing power infrastructure for government facilities. The military taught me that electricity doesn't care about your feelings or politics. It follows the laws of physics, period. Mess with those laws, and people die. I learned that lesson the hard way during a storm in the Persian Gulf when a power distribution failure killed 3 of my shipmates. Since then, I've been obsessive about backup systems, redundancy, and failure analysis. Atlas Strategic Solutions occupies 3 floors of a converted warehouse in downtown Denver. We design electrical infrastructure for military installations, federal buildings, and classified facilities that require security clearances most people will never see. It's the kind of work where a single calculation error can black out an entire base or worse. The company tries to look innovative with exposed brick walls and craft beer in the break room. But underneath all that hipster nonsense, we're dealing with life and death engineering. My office sits at the end of the 2nd floor, next to the server room where the constant hum of cooling fans drowns out office chatter. I like the isolation. From my desk, I can monitor the building's electrical systems on my secondary screen while working on client projects. Old habits from the Navy: always keep an eye on your power grid. The routine hadn't changed much in 17 years. Monday morning project reviews, where I'd present load calculations and system designs to clients who needed reliable power more than they needed pretty presentations. Tuesday through Thursday meant deep engineering work, transformer specifications, backup generator sizing, and the kind of detailed electrical analysis that keeps critical systems running when everything else fails. Friday meant documentation and preparing for the next week's challenges. I'd built my reputation on solving problems that stumped younger engineers fresh out of college. When a military radar installation needed power conditioning that could handle electromagnetic pulses, they called me. When a classified research facility required electrical systems that wouldn't leak information through power line fluctuations, I designed the solution. When backup generators failed during actual emergencies, I figured out why and fixed the problem permanently. The work suited me. Numbers don't lie. Physics doesn't play politics, and electrical systems either work or they don't. There's no middle ground, no corporate spin that can make a failed transformer look like a success. You either keep the lights on or you don't. That's why the Patriot defense contract felt different from the start. The Patriot project landed on our desk in early March, carried in by Claire Johnson, our CEO, like she was handling enriched uranium. $42 million to redesign the electrical infrastructure for 15 military installations across 4 states. The kind of project that defines careers and keeps companies running for years. Everything had to be built to withstand electromagnetic pulse attacks, handle classified equipment loads, and maintain power during combat conditions. "This is your specialty, Nathan," Claire said during our initial meeting, her voice carrying the weight of someone who understood exactly how much this contract meant to Atlas. 25 years of military and civilian electrical experience. The client specifically requested an engineer with naval systems background. I started mapping out power distribution systems that same afternoon. The math was complex but familiar, load calculations that accounted for radar systems drawing massive amounts of power in milliseconds, backup generators that could run classified computer systems for weeks without grid connection, and electrical isolation that would prevent any information leakage through power fluctuations. I'd done similar work for naval vessels under combat conditions. The only difference was scale and the fact that these bases would never leave port. Each installation needed custom solutions based on their specific mission requirements. A missile defense facility in Colorado had different power needs than a communications center in Virginia. For 6 weeks, I worked 12-hour days developing specifications that would keep critical military systems operational no matter what. The designs incorporated lessons learned from 8 years of naval service and 17 years of civilian contracting. Every calculation was checked 3 times, every backup system had its own backup, and every potential failure mode was analyzed and addressed. The preliminary designs were solid, bulletproof electrical systems that could handle anything from solar flares to direct enemy attack. I'd built in redundancy that would make a submarine jealous and power conditioning that could clean up the dirtiest electrical supply. These weren't just power systems, they were the electrical equivalent of body armor for America's most critical defense installations. Then Sophie Clark showed up and everything went sideways. Sophie walked into Atlas on a Tuesday morning in mid-April, like she owned the building's electrical meter. 32 years old, Stanford MBA, with a resume that read like a consulting fairy tale written by someone who'd never actually had to keep anything more complex than a coffee maker running reliably. She'd allegedly transformed electrical contracting at 2 Fortune 500 companies and revolutionized power system procurement for some tech giant in California. The whole office was buzzing before she'd finished her first cup of coffee. Claire Johnson introduced Sophie during the morning all-hands meeting at exactly 8:30 a.m. Sophie will be leading our client engagement on the Patriot Defense Project, she announced while Sophie stood there radiating the kind of confidence that comes from never having your calculations checked by Navy engineers who've seen what happens when the lights go out during a missile attack. She brings innovative thinking and proven federal success. Her approach to government contracting will transform how we serve defense clients. Then, almost as an afterthought that would define the next 3 months of my life, Nathan will handle all technical design, engineering analysis, and system implementation. Handle. That word that means everything and nothing. In the Navy, we had a saying, handle means you do the work while someone else gets the medal. It meant I'd design the systems while Sophie took the credit. It meant my name might appear in the footnotes while hers went on the cover page. It meant another year as the invisible engineer while someone else collected handshakes and bonus checks. I'd seen this pattern before. 3 times in 17 years, I'd watched project managers arrive with impressive credentials and compelling presentations, only to discover they couldn't tell the difference between alternating current and direct current. They spoke fluent PowerPoint but couldn't read a load calculation if their career depended on it. Sophie found me that afternoon at 2:15 p.m. She didn't knock. Military protocol teaches you to announce yourself before entering someone's workspace, but corporate climbers apparently skip that part of basic human decency. "You must be Nathan," she said, flashing a smile that belonged in a toothpaste commercial. "I've heard you're the technical genius around here." The compliment felt manufactured, like something pulled from a management book about handling difficult engineers. Her eyes scanned my office, taking inventory of my naval commendations, deployment photos, and the stack of electrical code manuals that most people used as doorstops. "I'm excited to collaborate," she continued, leaning against my doorframe like she'd bought the building. "I have some disruptive ideas about the Patriot Project that will revolutionize their power infrastructure approach." I smiled politely while mentally calculating how many hours I'd waste explaining why you can't revolutionize the laws of thermodynamics. "I'd love to hear your thoughts," I said, genuinely curious about what revolutionary approaches she'd developed during her first 6 hours at a company that specialized in keeping the lights on at classified military facilities. Sophie's revolutionary approach, as it turned out, involved leveraging smart grid technology to optimize power distribution efficiency. Translation: she wanted to connect critical defense systems to the commercial power grid because it seemed more cost-effective. When I mentioned that classified facilities require isolated power systems for security reasons, she waved dismissively. "Those are legacy restrictions. Innovation requires challenging outdated protocols." I'd heard similar logic from junior officers who thought established procedures were suggestions rather than lessons written in blood. The difference was that in the military, ignoring safety protocols got you court-martialed. In corporate America, it apparently got you promoted. The Patriot installations handle classified radar systems, I explained carefully. Any connection to commercial power grids creates potential information leakage through harmonic analysis of power consumption patterns. Enemy intelligence can determine operational status by monitoring electrical draw. Sophie's smile never wavered. That's exactly the conventional thinking we need to disrupt. Sometimes breakthrough innovation requires calculated risks. Over the next 3 weeks, Sophie's collaboration style became crystal clear. It started with small requests delivered via email with corporate politeness. "Nathan, could you send me the load calculation spreadsheets for the Colorado installation? Need them for client communication." Then escalated to demands with tighter deadlines. "I need the backup generator specifications for all 15 sites by end of business today." Meeting with Patriot tomorrow morning. No please, no thank you, just expectation wrapped in the assumption that my time belonged to her schedule. In the Navy, we called this delegating up, when someone with higher rank but less knowledge dumped work on the people who actually knew how to do the job. By week 3, she was forwarding client emails with "just handle this" typed at the top. Technical questions about power conditioning, electromagnetic shielding, and fault tolerance that required years of experience to answer properly. When I suggested including her in technical calls so she could understand the specific engineering requirements, she explained that her time was better spent on strategic visioning while I focused on tactical implementation. The translation was becoming clearer with each interaction. Sophie would attend high-visibility meetings with executives while I handled the actual work of understanding client needs, researching federal requirements, and developing solutions that wouldn't kill people. She'd present my findings as her insights, my frameworks as her innovations, and my 25 years of military and civilian electrical experience as her natural business instincts. Oliver Quinn, our 28-year-old junior electrical engineer, noticed the pattern during one of our weekly mentoring sessions. "Nathan, Sophie's presenting the power distribution analysis you developed for the Virginia site." She told the client it was based on her previous experience with federal electrical systems. I'd been mentoring Oliver for 2 years, teaching him the same way my Navy chief had taught me, through careful observation, strategic guidance, and protecting him from mistakes that could end careers. "Watch everything, document everything," I'd told him during his first week. In corporate warfare, just like military operations, situational awareness keeps you alive. He was learning faster than I'd hoped he'd need to. The breaking point arrived on a Thursday evening at exactly 7:15 p.m. I was deep into calculating transformer load distributions for the missile defense facility in Colorado when Sophie burst through my door without warning. Military training teaches you to read body language and energy signatures. Sophie's posture radiated entitlement and urgency, the combination that usually preceded unreasonable demands involving other people's work. "I need your login credentials for the Patriot project folders," she stated. Not requested, stated. "I'm assembling a presentation for tomorrow's client meeting and need immediate access to all engineering files." In the Navy, unauthorized access to classified systems was a court-martial offense. In corporate America, it was apparently standard procedure for rising stars. "Those folders contain working calculations," I replied carefully. "They're not presentation ready. Some files show preliminary designs that haven't been safety checked yet." She waved dismissively. "I understand what I'm doing. I just need to pull some frameworks for the client update. Email me the credentials." I could have explained security protocols. I could have insisted on proper authorization. I could have escalated to Claire Johnson and demanded clarification about file access policies. Instead, I remembered something my chief petty officer used to say. Sometimes the best way to teach someone about electrical safety is to let them stick their finger in the wrong socket. "I'll send you the credentials," I said, maintaining professional neutrality. "Everything you need should be in the project folders." As her footsteps faded down the hallway, I sat staring at my monitor for exactly 3 minutes and 47 seconds. 17 years of watching my work disappear into other people's presentations, being told I wasn't leadership material, while leaders presented my designs to clients who trusted my calculations to keep their people alive. Something crystallized, not anger. Anger burns too hot and too fast. This was colder, more precise. This was calculated resistance. I opened a new folder on my desktop and started typing. Patriot Imprel deliverables NP-, my initials barely visible at the end. The trap was about to be set. Creating those dummy files felt like designing a controlled electrical failure. Each document needed to look professional enough to pass casual inspection, but contained fatal flaws that would trip every safety breaker in the Pentagon's procurement office. File 1, Power Distribution Analysis. Beautiful load calculation spreadsheets with color-coded efficiency charts that would impress any MBA who'd never had to calculate actual amperage under real-world conditions. But underneath the polished presentation, I'd embedded a critical error. The entire system was designed for commercial voltage standards instead of military specifications. Any electrical engineer would spot this immediately. It's like wiring a battleship with household current. The beauty was in the details. I used accurate transformer specifications, but sized them for 208-volt commercial service instead of 480-volt military standards. The load calculations were mathematically correct for the wrong voltage. Someone presenting this to defense contractors would be recommending electrical systems that couldn't power a military radar array without immediate transformer failure. File 2. Backup generator specifications. Detailed equipment recommendations with accurate costs and delivery timelines pulled from real vendor catalogs. The fatal flaw was subtler. I'd specified generators that couldn't handle the inductive loads of military radar and communications equipment. They'd fail within hours of a power emergency, leaving critical systems dark when soldiers needed them most. I spent 4 hours researching generator specifications that looked impressive on paper, but couldn't handle the power factor requirements of military electronics. The generators I recommended would work perfectly for running office buildings or shopping centers. They'd destroy themselves trying to power a missile defense array. File 3. Security Protocol Compliance. This was my masterpiece. A framework that looked comprehensive but recommended power systems that violated basic tempest shielding requirements. Any facility built to these specs would leak electromagnetic signatures like a broken radio, advertising the location of every classified computer system to enemy surveillance. Tempest shielding requirements aren't classified information, but they're technical enough that most business school graduates don't understand why power systems need electromagnetic isolation. I'd created specifications that would pass corporate review while failing basic military security standards. Each document included my standard file naming conventions and digital signatures embedded in metadata, with creation timestamps showing work completed weeks before Sophie even arrived. Military logistics had taught me the importance of documentation trails and evidence preservation. I also implemented a digital monitoring system using basic IT protocols. Every time Sophie accessed the dummy folders, my background script logged the activity. When she downloaded files, I knew exactly what she'd taken and when. When she renamed documents to remove my initials, I had screenshots of the file properties showing the modification history. The IT department's access logs would provide additional verification if anyone questioned the timeline. Everything was documented, everything was traceable, and everything pointed to unauthorized access of engineering files that were never intended for client presentation. Sophie took the bait within 2 hours of receiving the credentials. My email was simple and professional. Here are the credentials for the Patriot Project folders. The files in Patriot horizontal deliverables should have everything you need for tomorrow's presentation. By the next morning, she downloaded everything. I watched the access logs like a technician monitoring power consumption, methodical, patient, documenting every spike and fluctuation. She'd accessed the dummy files 7 times between 8:30 p.m. and 11:45 p.m., downloading each document multiple times and spending significant time reviewing the contents. The most satisfying moment came during our weekly team meeting the following Tuesday. Sophie stood at the front of the conference room presenting my sabotage specifications with the confidence of an admiral briefing the Joint Chiefs. I worked late last night developing these engineering solutions, she announced, pointing to diagrams I'd created 3 weeks earlier. The efficiency improvements are groundbreaking. Oliver Quinn, our junior electrical engineer, raised his hand. The kid was learning to spot problems faster than I'd hoped. That voltage specification seems off for a military installation. Are we really using commercial power standards for classified equipment? Sophie's smile never wavered, but I caught the micro-expression of someone scrambling for technical justification. That's exactly the conventional thinking we need to challenge. Sometimes innovation requires bold moves that make traditional engineers uncomfortable. She clicked to my intentionally disastrous backup power plan. Look at these cost savings. This is why Patriot hired us to revolutionize their approach. I maintained neutral expression, taking notes like a supportive team member. Internally, I was cataloging every false claim, every technical misrepresentation, every moment she passed off my poison calculations as breakthrough engineering. The following weeks became a careful dance of calculated support. Sophie would demand new specifications, always urgent, always last minute. I'd provide them from my special folder, each file a precisely engineered failure waiting to detonate under scrutiny. She started sharing them directly with Patriot's engineering team, attaching her name as lead designer, occasionally remembering to credit me in footnotes as technical support. The irony was perfect. She was building her entire professional reputation on electrical designs that would fail catastrophically if anyone actually tried to build them. Meanwhile, I maintained 2 parallel workflows. The dummy files continued feeding Sophie's growing confidence, while I built the real strategy and secured folders only I could access. The actual Patriot analysis told a completely different story. Genuine power solutions, authentic load calculations, and actionable designs that would legitimately protect critical military installations. Every framework was documented, every assumption verified, and every recommendation grounded in 25 years of combined naval and civilian electrical experience. This was my insurance policy, waiting in the wings while Sophie performed her dance of destruction with my poisoned intelligence. The preliminary review with Patriot was scheduled for Tuesday, May 14th at 9 a.m. Sophie had already sent them the complete package on Friday, 73 slides of beautiful, catastrophic engineering. There was no turning back. The fuse was lit, and I had front-row seats to the explosion. The Patriot Defense Conference Room was built for serious business. Awards from defense innovation competitions lined the walls, photographs of decorated veterans covered another, and a conference table dominated the center, large enough for 20 military engineers and procurement officers. 118 people filed in that Tuesday morning, including Maya Rodriguez, Patriot's CEO and former Air Force colonel who'd built her defense empire through disciplined execution and zero tolerance for contractor incompetence. Her handshake could crack steel, and her questions had ended more than one consulting contract. Sophie's Stanford MBA wasn't going to impress someone who'd kept the lights on during actual combat operations. Sophie clicked through her opening slides with practiced confidence, building toward the engineering specifications that would either seal the $42 million deal or sink it like a torpedo destroyer. Slides 1-4 covered safe territory, company overview, project timeline, regulatory compliance. She was establishing credibility, setting the stage for the technical payload. Then came slide 5, power distribution design. The moment my corrupted voltage specifications appeared on screen, I watched Colonel Maya Rodriguez's expression shift from polite attention to professional alarm. Sophie had just recommended wiring a classified military installation with commercial power standards. Can you explain this voltage configuration? Maya asked, her voice maintaining diplomatic neutrality while her eyes telegraphed serious concern. Sophie's confidence never wavered, but I caught the slight tremor in her hand on the presentation remote. Our analysis shows significant efficiency gains using optimized power standards, she replied smoothly. These recommendations represent paradigm-shifting approaches that will revolutionize military electrical infrastructure. Victor Hayes, Patriot's chief engineer, leaned forward. He'd spent 30 years keeping power flowing to everything from submarine reactors to missile defense systems. Miss Clark, you're recommending 208-volt distribution for equipment that requires 480-volt three-phase power. This would damage every radar system and classified computer on the base. That's exactly the innovative thinking we're proposing, Sophie said, though sweat had started beading on her forehead. Sometimes revolutionary engineering requires challenging traditional electrical constraints. Slide 6, backup generator systems. Now even junior engineers were exchanging concerned glances. Whispered conversations erupted across the room. Maya pulled out her tablet, cross-referencing Sophie's recommendations with actual military power requirements. These generators can't handle inductive loads. They'd fail the moment radar systems came online during an emergency. The room temperature seemed to drop 10 degrees. Voices rose as electrical engineers identified additional problems. Why are you recommending equipment that violates tempest shielding? How can these power systems handle classified computing loads? Are you seriously suggesting we connect defense networks to commercial grid infrastructure? Sophie retreated into consultant buzzwords about disruption and efficiency optimization. Each answer dug the hole deeper. The military engineers were exchanging the kind of looks that usually preceded immediate contract termination. Then Maya asked the killing question, her colonel voice cutting through the chaos like a blade through copper wire. Do you understand military electrical systems at all? Silence fell like a circuit breaker tripping. 18 pairs of eyes locked on Sophie. Her mouth opened, closed, opened again. No words emerged. The confident MBA had finally encountered calculations that couldn't be solved with PowerPoint animations and business school jargon. Victor's voice was quiet, controlled, lethal. Mr. Pierce, do you have anything to contribute? Every head turned toward me. Sophie went pale, finally understanding that her house of cards was collapsing in real time. I stood, smoothing my jacket with the deliberate calm of someone who'd spent 8 years maintaining power systems under combat conditions. Yes, Mr. Hayes, I do. My laptop was already open, real specifications loaded, grounded in 25 years of combined naval and civilian electrical engineering experience. May I? I held up the presentation cable. Maya nodded curtly. Please do. As I passed Sophie, frozen like a deer in headlights, I felt 17 years of invisibility dissolving like resistance heating in a bad connection. The screen flickered. Her fantasy vanished. Reality appeared. Military-grade 480-volt distribution systems, I said, voice steady and professional. Isolated from commercial grid infrastructure to prevent electromagnetic compromise of classified systems, Maya leaned forward, relief visible in her posture. These specifications match our security protocols exactly. I walked them through the real engineering, isolated power systems, military-hardened backup generators, Tempest-compliant shielding, and fault-tolerant designs that could maintain power through enemy attack. Every calculation was rooted in actual physics, supported by naval engineering standards, and designed to keep critical systems operational when lives depended on reliable electricity. 45 minutes later, the room had transformed from hostile interrogation to collaborative engineering discussion. Questions became implementation details. Concerns evolved into optimization opportunities. Finally, Maya raised her hand, calling for order. Mr. Pierce, if you had this level of engineering expertise available, why were we initially presented with that? She gestured towards Sophie, still frozen against the wall. I pulled up my evidence folder with the same methodical precision I'd once used to brief ship captains. Complete transparency. Timestamps, access logs, file metadata, digital forensics. The flawed specifications were preliminary working documents never intended for client presentation. They were accessed without authorization and presented as final engineering work. Victor scrolled through the documentation on his tablet, his expression darkening with each revelation. The metadata shows clear evidence of unauthorized access and systematic file manipulation. Maya stood, her command presence filling the room. We're proceeding with one modification. Nathan Pierce leads this engagement. Non-negotiable. Sophie's face went ashen as her corporate dreams short-circuited in real time. Back at Atlas Strategic Solutions, news traveled faster than alternating current through copper wire. Sophie was gone within 2 hours, escorted out by building security while HR handled the legal implications. By 3 p.m., Claire Johnson announced to the entire company, Nathan Pierce is now our Director of Defense Engineering. For the first time in 17 years, I wasn't invisible. 6 months later, the Patriot project completed ahead of schedule, under budget, and exceeded all military specifications. The invisible engineer was gone. In his place stood someone who understood that sometimes the best electrical system isn't the most complex one, it's the one that works exactly as designed when people are counting on it to keep them alive.